Welcome to our session about Azure Container Instances. So, why we are here? So we have this new great service called Azure Container Instances. So we're going to spend 45 minutes, me, Carlos, talking about it. We come from this. We just had a great hackathon called OpenHack in Amsterdam. That's why we are a bit tired. We are not completely prepared, but please bear with us. And there's a fun fact that I have to tell you. So when we decided to propose this session, we couldn't fathom or predict that most of the team behind ACI, so all the program managers and all the developers, they are sitting in the back. So they are watching us very carefully. So there's no pressure for us. But we decided to apply to send this proposal because we just like this stuff, right? So we love containers. We both technical evangelists or software developers, as you call it nowadays, in Microsoft. We love containers, and that's why we decided to share with you our experience with this new service called Azure Container Instances. So what is Azure Container Services? So you can see it as a serverless container, so a container where you don't need to spin up an entire infrastructure to just run one container or 10 or 100, or a containerized infrastructure as a service, so when you run your services in containers in your cloud. So this is the rationale behind it. So we, at Microsoft, because we like containers and we want to give our customer the best way to run it, we decided containers should have been at parity with every other resource in Azure. So we actually have a resource provider, RP, like we have for EAS, like we have for databases, like we have for almost everything in Azure. So containers are now, or the service is in preview, so we will soon, I hope soon, release a GA. But so containers will be just objects in Azure, resources, at the parity with VMs, SQL databases, whatever you think of. So we would like to have containers as first-class citizens inside Azure. And we want to give a seamless and easy experience for people that want to run containers but don't want to run whatever comes attached to it, whatever you need to run containers. Most of the time is an orchestrator, or at least a bunch of VMs, at least one VM to run your containers, right? So the service is designed to run one or multiple containers. We are extending it. It's the first iteration, so it's not complete by far, but we like to get feedback from you to learn where we should aim it. And why it matters, because it kind of realized the dream of DevOps. When I started talking about DevOps 5 years ago, there was this thing like, are we going to all lose our job because there won't be any operation needed? So in this case, it's kind of true. You don't need to take care of VMs, so you kind of outsource to us all the nitty-gritty details of running VMs to run containers. Why would you want to run 10 VMs for Cloud Foundry when you just want to run your application in a container quickly and scalable? Of course, so this service for us is a building block for something else. So we just provide you with a very simple interface, which we promise to never change. So you will always have the same interface to Azure to run containers. And you use that to run containers that can do something else. So if you want to orchestrate containers, you can use Azure Container Instances to build something more sophisticated. So why? Again, so because it's the fastest way to run containers today in a cloud. And I bet you to contradict me. So Carlos will demo it. Containers spin up very fast. So if you have a faster way to run containers, please let us know, and I'll pay you a beer. And of course, there is no VM management. There is no attachment, no string attached, or no VM attached, as you say. And that's also, and the other great feature is per second billing. So from the moment you run the container to the moment you stop the container, that's the only moment where we're gonna charge you for the service. Not before, not after. If you leave it running, of course, if you forget it on, you're gonna have a hefty bill from Azure, but this is meant to be a service that you don't use one by one, but use programmatically, and we show how to use it in a context of an orchestrator or when you need an orchestrator. And of course, you can also integrate with Docker Hub and the private registry that we run in Azure. If you know it, you should get used to it. It's just our version of Docker Hub. It's private. It runs in your subscription and is protected by your credentials or service principal. So today you can run this. It's a preview service, of course. We don't have an SLA attached, and we are still figuring it out exactly the feature that we want to put it there. But you can run it today, and there are different ways to run it, and we will show you 2 or 3 different ways to run it. It's available in, I think, all regions, or if not, for sure in Western Europe and the main regions. So, ways to deploy ACI. Of course, the portal, that's the simplest experience you can think of. Like, there's a tab called Azure Container Instances. You get all the documentation from there. It's very simple. You just select the image you want to run and the resource group, and bam, you have a container running in Azure. Of course, we have the CLI experience, the native Azure CLI. You can install it on Mac. It's multi-platform. You can run it directly from the Cloud Shell. Or you can use an ARM template, Azure Resource Manager template, because everything in Azure is described as a template, is a resource. So there is always a JSON template you can use. And after that, I'll give it to Carlos.
Thank you.
For exactly showing this.
So thank you, Alessandro. So what I'm going to do now is demo you the main ways on how to deploy containers to Azure Container Instances. And one of my favorite ones is, well, just using Azure CLI, which is quite straightforward. So I'm going to start by just deploying an image which is basically, well, has like a Node app, web app running. So you will see how straightforward it is. So I believe that everyone can see the command line pretty well. So just going to get started. So it all starts, of course, when you're deploying stuff to Azure, you need to have a resource group, right? So let's just quickly create one. So we start with Azure group create, then we give it a name. Let's say TechDays 2017, Amsterdam, and location will be, Western Europe. All right. So if everything goes smoothly, hopefully, we should have a resource group. And now we start actually interacting with the container instances service also by the CLI. So like I said, I'm just going to deploy a simple container. So we say Azure container create. So if you're curious around the sort of command lines that it's supported, you can easily do help on this, and you'll see what parameters you can put in. But let's, for the sanity of time, let's just focus on the creation now. And we say, okay, name, I'm going to name it ACI Hello World. And I'm going to get an image from the Docker Hub from Microsoft, which is called Microsoft /ACI World. Then we need to tell it to which resource group it needs to go. So we say the one we just created. And this is one of the cool things about Azure Container Instances. We can literally say, hey, spin up this simple web app, put it running on a container instances, and I can just say this: I want a public IP address, so that I can immediately, check out what's being served there. So we say IP address public. So if my command was okay, but it wasn't, so resource was a typo. We should have a container instance already provisioned. So it's sort of, you know, as you can see here from the provision state, it's creating. Normally it's quite fast. So what we do, we can immediately follow with another command that basically we can check the status of the deployment. So I'll just use my so Azure Container show, and no, I don't need the image, of course. I just need the name. And boom, it succeeded. So as you can see here also from this JSON response, here's my public IP address. So I can just grab this guy, and I'll move a window over here. Can go here, and boom, that's it. It's really straightforward. So this is one of the most simple ways to deploy a container in Azure Container Instances. Another interesting thing that you can do is also check what's happening inside the container while it's running. So again, we can go here to the command line and say, show me the logs instead. And what you see here, well, but when the container started, it just outputted this, you know, listening on port 80. So as you remember from my original command, I didn't even specify a port. I didn't specify what sort of container spec I wanted, Linux or whatever. So it just defaulted to Linux. So we'll get to that later. But as you can see, well, here are my requests that hit that endpoint, basically. So this is quite straightforward. What you can also do, and I'll move it to this window as well, is go to the portal and see, well, pretty much the same, but of course on a graphical user interface on the portal. So here is the container running. As you can see, there's nothing, well, there's not a lot of information to display here, but well, you get the point. So I'll just delete this guy. All right. So the second way that you can also deploy is also, of course, the command line, but using the ARM templates, like Alessandro was referring. So I'm going to show you here a pre-baked one that we have, Build Studio Code. And I mean, I assume everyone is familiar with ARM templates? Yes? No? No? Okay. So as Alessandro referred, ARM templates is a way for you to, let's say, spec out what sort of Azure resources you want to provision. And then, well, basically you have like a thorough definition on what you want in pretty much all Azure services. You save it, and then you tell Azure, hey, here's what I need. I need storage, I need container instances, I need an app service, I need a VM, etc. So everything can be specced out on this template, resource manager. And then, yeah, Azure takes that and starts provisioning. So it's quite straightforward. So for this, what we're having, what you see here, yeah, you can see it quite well. We have a little bit of a different, let's say, container. It's basically composed by two containers. So we call this a multi-container group, basically. And from what you can see, if you see the thing called variables, what I'm doing is saying, hey, provision one container based on this little other image that I just showed you guys, an ACI Hello World. And also provision me this other container based on the image, which is called ACI Tutorial Sidecar. So what this is doing, basically, this ACI Tutorial Sidecar, it's basically running a little script that does a curl to the other URL so that it just proves that it's alive. So you see interaction between these two containers while they're running. So as you can see here, you have way more detail and, let's say, a little bit more control on what you're provisioning. And, well, for example, like I said, you can specify what, number of CPU cores. You can specify the memory, how much memory you need. You specify which ports you want to open, if you want a public IP address, the operating system type. So we support Linux and Windows. So this will provision a Linux one as well. And that's it, basically. So what I'm going to do is just provision this guy. So I'm just going to grab, for the sake of time, my pre-baked command line. So Azure group deployment create, please create me this multi-container container group in the same resource group. And as you can see at the very end, hey, there's the template file. Please go and fetch it and deploy. So while it's doing what it's supposed to do, so this will take, well, less than a minute, I will quickly go and show you the portal experience on how you can also deploy images to Azure Container Instances. So one of the really cool things is that, for example, if you're familiar with Azure Container Registry, so Azure Container Registry, I think I have here a really quick definition of what it is. It basically allows you to have what we call a private registry, so you can store and manage your images, Docker-based, etc. So what we did, we create a container registry also here in Azure, and we have an image there. So I'll show it to you in this repository. By the way, it's the same one that I have. And what you can do, it's really cool. So you can just literally right-click and say, run this new container based on a new instance. And what it will do, so it allows you to easily create a container instance. And, well, you specify the same sort of parameters we had on the command line. And boom, voila, it's running. You can also deploy to app service. So if you guys know, we also support containers on app service. So you can also easily deploy there. So it gives you a lot of options. So that was it. Okay, so back to our command line. As you can see here, we have the deployment it's already succeeded. Well, that's quite nice. So, but what I would like to show you is the logs of the provision state, let's call it. So as you can see, we have one container group with 2 containers running, and there's the public IP address. So again, we can easily just quickly check it if it's running. So I think you don't need to buy beers to anyone, right? It's quite fast. We'll go here, press enter, boom, there it is. So I would like also to show you what this ACI tutorial app, so this really simple Node.js app is doing, but let's check what the other container is doing. So I'm just going to grab here the command, paste it, and, well, need to scroll up a little bit because it's running for some time now, and it's outputting a lot of logs. But as you can see, it's essentially hitting a curl on the other guy every 3 seconds. So yeah, that's what it's doing. So you see these 2 containers talking to each other, basically. And so what we can do also is go check the logs of the other container. So tutorial app. And you see that there's, well, as you can see, each 3 seconds there's a hit. So this also, you can imagine scenarios like, okay, you have like a web app, a front end, and then you have the API that it's sort of the back end of your app, and you can have it running on Azure Container Instances. Yeah, so back to you, Alessandro.
So great, no beers for nobody.
Sorry.
Just for the team that build this stuff. So how does it work, really? So this idea of having multiple containers in a container group is kind of for somebody that knows what Kubernetes is and kind of reminds the idea of a pod. In fact, that's how it works. We have pre-provisioned resources in Azure where we run this stuff. So we create a container group when you request one, and we run your containers in there. And the containers can talk. You can see it in the demo. You can curl localhost and talk to the other container. So, and then we expose ports, but of course there is a limitation in there. We cannot expose multiple ports, but for now, bear with us with the simple use cases of just exposing one container to the outside, and the other can expose a port, but it cannot be exposed through the public IP. So very simple stuff. If you have questions, please interrupt us as we go. So a note about billing. So this thing is not free, of course. There's a small charge when you start a container. a few cents, and then we bill per second per unit of computing, right? So I think the limit now is 4 vCPU and 8 GB of RAM. We might increase it, I'm not sure, but we charge this pennies per second of execution, right? So this is interesting to understand, because if you run a container for a month, the same container, 1 GB, 1 virtual CPU, you run it for a month, it's how many seconds in a month? A lot. That makes $60, right? So it's more than a VM. Definitely, this is not the sweet spot for Azure Container Instances. That's not meant to have long-running workloads or application served through Azure Container Instances. We didn't made it for that. But if you look at the second use case, when you can run many containers for just an hour each, 1 hour each, and a bit more beefy, then you have a much smaller bill. So it depends on your workload. Maybe you do want and need an orchestrator, or maybe you do just need a web app. I have a slide later to kind of give you some indication what is in the where. But that's something you have to keep in mind. Don't just run containers running. Please switch off yours before they run.
We will.
Okay. So use cases that you can. So I don't know if this stimulates your imagination. Maybe you have some use cases that you can give feedback to us, and we can work together. So if you can run a container on demand, you can do a task automation. So a container does one thing and dies, and then maybe every hour come up, do one thing, and then dies. You can think of running CI/CD build agents or deployment agents in this. You can build your packages in containers and then push it to a repository. There's a video on channel 9 on that. Small-scale batch processing, when you have data. By the way, you can also talk about it. You can mount volumes from Azure file. So maybe you have a data set there, a container that comes up, does something with this data, and then dies again, or on-demand web apps or API, but not long-running workloads.
Yeah.
So what is not ACI? It doesn't do a bunch of stuff, right? I mean, it's by design. The people that came up with this idea of ACI, they just wanted to have this as a building block for something bigger. So it doesn't do auto-scaling. You cannot say, well, I'm running one container now, please run 10 copies of that. It's not meant to serve that purpose, or at least the tooling around it is not. They don't give you doesn't make it easy. So it doesn't do upgrades. If you want to replace the image with a new version, you have to kill the container, run another one. It doesn't do service discovery. It doesn't have sophisticated DNS service discovery like Kubernetes, but that's on purpose, and doesn't do complicated load balancing like ingress or whatnot. So if you need all this stuff, then you need an orchestrator, right? So what we're gonna demonstrate soon is how you integrate ACI into an orchestrator. So if you still need all this stuff, but you want to have the flexibility of ACI, so per second billing, no management of virtual machines, and you want fast startup, then you may look at something that we call ACI Connectors, Azure Container Instance Connector. There is one now on GitHub that is for Kubernetes. We probably won't develop a bunch of those. We would like other people, other partners to develop those. But we have one that works with Kubernetes, and I can show you why and how it works. So imagine that you have a Kubernetes cluster, and then you want to extend it with ACI. So ACI is just, think of it as an infinite pool of resources where you can run containers, but orchestrated by the Kubernetes API. So familiar interface, familiar API. Kubernetes is very popular now. Everybody knows it, I hope. Who doesn't know Kubernetes around here? Show hands. Well, everybody knows it. So I'm not saying something weird. So Kubernetes is a great orchestrator, but you still have to manage VMs. And what if you could just use ACI to, for example, burst workloads into ACI? So let's say you fill up your VMs and you don't want or can't spin up more VMs, then you can just use the connector, the ACI connector, to just extend the Kubernetes cluster into ACI. It's a pretty nifty idea, and you can also destroy when the capacity is not needed anymore because you are not running those workloads anymore. Things goes away. So this is on GitHub. You can clone it. It's very simple, and I'll show you quickly or not so quickly. Depends if okay. So. Everybody can see it's pretty big. So I have a Kubernetes cluster running in Azure. ACS is our Azure Container Service. So before this afternoon, I just spin up a container cluster. So I have 2 nodes ready, and these are virtual machines, right? So classical virtual machines in Azure. So great. Now I can just and this is how it works. That's the repository on GitHub. You can see the ACI connector is a deployment in Kubernetes. So just what you can recognize as a deployment, that's what it says on top. But it needs some parameters, some secrets, and the subscription ID, and the tenant ID, and the resource group, because it's going to use those to create resources in Azure on your behalf. So I pre-populated those. All right. So yes. So you can see now there is a deployment called ACI Connector, and there is one pod called ACI Connector. Let's look at the logs. If everything is right, we just have the logs. It's starting up and it's talking to the Azure API, and everything is fine, and spin up some services, internal services. So what do I do now? You can see there is a new node added to the cluster that is not really a node. You got labels and stuff. So show labels. So you got well, not really, but the other ones have the labels. But my point is, you can identify this node by name, right? So you can nginx pod.yaml. So you can schedule pods on this node specifically by calling it out by name and say this pod has to run on a node called ACI Connector. So the other way is to use, and I don't know if it's, yes, is to use tolerations. So you would need to specify the labels on the node, and then you tolerate that those pods end up on those nodes. That's a more flexible way to deal with this. So tolerations, it's been introduced in 1.6, if I remember. So this says run these pods and run it anywhere you want, and you can tolerate to run them in nodes that are also ACI labeled with this key. So that's the burst case, the burst where you run everything in VMs or wherever you can or you want, and then you can burst up into ACI. But in our case, we're going to make a simple one. So you have one pod, it's already running. And you can see there's an IP address already assigned to the pod, because that IP address comes from ACI. So Kubernetes, through the ACI connector, it created resources in Azure, and one of the resources, this nginx pod, that just shows you the fancy page of Nginx. So that's how the connector works. It's again like a simple proof of concept, but think what you can do with it. So now that we talk about the connector, we have a few minutes left. So you might be confused now, what do we do with all this? So we have at least 6 ways to run containers in Azure. Maybe it's too much, maybe we should consolidate eventually, but this is all very different use cases, right? So Azure Container Instances, we just demonstrated, is for this transient, like ephemeral workloads that don't fit anywhere else, so you want to run them and you want to be built per second. Of course, you have the fully fledged container service, which lets you spin up entire orchestrators like Docker Swarm, Kubernetes, or Mesos. So it's more intensive, both from the building perspective. You have to manage your own VMs. It's not for everybody, clearly, but it's a very effective way to run containers in Azure. We have something now called Web App for Containers, which used to be called Web App for Linux. It's our web app, so with all the things that come with a web app, all the tooling, the logging, everything, the app inside, for example. And nowadays also supports running containers straight from Docker Hub or another registry. You have the container registry, of course. You have Service Fabric, great orchestrator for Windows and Linux containers. And you have Azure's Batch, which is another way to run containers. It also supports containers to run batch jobs at scale. So if you are confused, don't worry. We also are a bit. And but there is a place for everyone in Azure to run containers. So what we can do now, today, so we can run Windows containers since like a couple of weeks. So we support running pulling images, both Linux images and Windows images, and we run it in the right hypervisor, so in the right containers, of course. You can set up your own limits, gigabyte and CPU, right? You can attach public IP, you can attach Azure files, so you can create, and you have to pre-create it. You cannot dynamically create it, unfortunately, but maybe one day will come. So it's a file share in your storage account, can be attached to the container, to the running container. So containers can share files and a file system with other containers. So you can override the entry point, you can pass environment variables to the container. And you can log, like Carol showed. So we want to make this exactly like VM, so parity in features, also to the classical Docker run command. So the ability to attach the container, ability to expose multiple ports, and a very well requested feature is to have private VNet between containers in a container group, so you can attach other things in Azure, other resources like a VM to that VNet. And of course, we're working to get more connectors, more use cases, learn from experience. It's a preview service, so don't blame if it doesn't work. And so what do you want to build with it? We really would like to listen to your use cases. These are a few links. Most of it is based on a Ignite talk from Sean McKenna and the team.